Hello, we will continue the concept of work power energy, the related problems, the topic related problems. Given one problem, a particle of mass is m, move in a circular path with a constant, okay, with the circular path with constant radius. A centripetal acceleration k square rt square. Centripetal acceleration is variable, it is AC equals to k square rt square. Time dependent. Acceleration is time dependent. When acceleration is time dependent, acceleration variable. Centripetal acceleration is variable. Then it is non-uniform circular motion. Centripetal acceleration is variable. This is non-uniform. K square r into r square into t square. So V is write as kRt. The velocity variable with time. Speed variable with time. Speed variable with time. This is non-uniform circular motion, NUCM. Non-uniform circular motion. There are two forces in non-uniform circular motion. One is centripetal force, another one is tangential force. Centripetal force, the force toward the center, this is centripetal force. The force tangential, this is a tangential force. There are two forces in non-uniform circular motion, NUCM. So particle is revolving this circular path. There are two forces are there. One is tangential force, another one is centripetal force. Displacement or velocity always tangential. Displacement and velocity are tangential. So Ft and Fc, so both mutually perpendicular. So this is a non-uniform circular motion. There are two forces. First we considered the power due to centripetal force. Centripetal force, the power. So this is right as power equals to force into velocity into cos theta. So theta becomes 90 degree. Then the power becomes cos 90, its value becomes 0. Then power becomes 0. So uniform circular motion, power due to uniform circular motion only centripetal force. So power becomes 0. And work done also 0, uniform circular motion. Power 0 means power right as work upon time. Work also 0. But in non-uniform circular motion, so this is power due to centripetal force. This is 0. But power due to tangential force. This is right as Ft into V into cos theta. Theta becomes 0. Cos 0, its value becomes 1. Then P equals to Ft, m into At into this is V. Cos 0 value becomes 1 it is. M into tangential acceleration. Tangential acceleration write as dV upon dt. This is the tangential acceleration into. So this is power it is. You know that power equals to m into V write as kRt into dV upon dt. So differentiation of d by dt of kRt. Its value becomes, so power is write as P equals to m kRt into differentiation of kRt, that is write as k into r, where power equals to m into k square r square t. This is power due to tangential force. Power due to tangential force. Tangential force gives the power. Radial force gives 0 power. Radial force force gives 0 power. Radial force gives 0 power. Tangential force gives, that is m k square r square t. This is the power due to tangential force. This is related with graph. You know that area between force and displacement, area of force and displacement graph. So this is displacement and this is force. Area of force and displacement graph indicates that is work. Work is equal to area of Fs graph. This is work. But the condition here, the condition is given. Find the work done when x equals to minus 2 meter to x equals to 0. And x equals to 0 to x equals to 2 meter. Minus 2 meter to 2 meter. Three different problems are given. First one condition, first case, okay, problem 1. So problem 1. So displacement x equals to minus 2 meter to 0. This is the displacement. But displacement take it on x-axis, force take it on y-axis. So displacement is, this is the block which is moved from minus 2 meter to 0. The displacement moved from minus 2 meter to 0. This is the direction of displacement. And minus indicates only direction. So displacement from 2 to 0. So the distance from 2 to 0 it is. This is the distance from 2 to 0. That means here the magnitude decreases. Magnitude decreases means force is opposing force. Force is opposing. The force is F. And force and displacement, both directions are opposite, theta equals to 180. So force and displacement, opposite direction, theta equals to 180. Then work done equals to F as cos 180 it is. Fs cos 180. But the F value is changes. F value changes. So 0 to 10. This is the F value from 0 position to 10. That means we considered here average. Average force. Average force 0 plus 10 upon 2 into displacement is given, that is 2 into cos 180, that is minus 1. Then its value becomes, this is minus 10 joule. This is the work done when the displacement from minus 2 to 0. So this is the original condition, original method. But you know that very simple, the area of work, area of Fs graph, that is indicates work done. Area equals, it is like a triangular shape. Area equals to second method. This is, so second method, the work done we want of base into height. Base is given, this base is given, it is minus 2. So base is given 2, it is displacement. And here force is given, that is 10. But this is 2 into 10, this is 10 joule. But this condition, magnitude 10 joule. But here we using that the force is oppositely, it is acting, force is acting opposite, that means minus 10. So work done equals to minus 10 joule. Next, second question. So second one. Here the second question is x equals to 0 to 2 meter. X equals to 0 to 2 meter. That means this is the block. So the displacement from 0, this is 0 position, this is 2 meter. So that means the displacement is this. And force also positive it is. force also positive force is acting. Displacement increases from 0 to 2 meter. So displacement increases from 0 to 2 meter and force also supporting force. This condition work done equals to Fs cos 0. But this is average force, not uniform force is acting here. The force is changes from 0 to 10. We using average. Its value 0 plus 10 upon 2 into S. S is right as 2 meter into 1. Its value becomes 10 joule, but it is plus. Work is plus it is. Using the graph, W equals to half base. So half base is, that is 2 meter, height is 10. This condition work done, we consider this is 10 joule. This is the positive work, that is 10 joule it is. And third condition, the third condition, x equals to from minus 2 to plus 2. Minus 2 to plus 2, there are two conditions of work. First case the work is minus 10 joule, second condition work is that is plus 10, then W equals to W1 plus W2. First the work is minus 10 and second the work is plus 10, the total work done becomes 0. So from minus 2 meter to 2 meter, the displacement becomes, that is, the work done becomes, that is 0 work it is. So this is positive and this is negative. The work becomes 0. So another problem is given that an object is displaced from the position vector. R1 is given and R2 is given. Force is 3x square I cap, 2y j cap, 4z k cap. We want the work done by this force. This is variable force it is. Force depends upon displacement vectors. So this is variable force. In variable force, using the work done is dW is right as F into dr. F bar dot d bar. Dr, this is position vector. F is given, F bar equals 3x square I cap plus 2y j cap plus 4z cube into k cap. So this is dr bar. Dx I cap, dy j cap plus dz k cap. So it is right as dw, this is right as f bar dot dr bar. Using this value, 3x square I cap, 2y j cap, 4z cube k cap. So this is f and into dr right as dx I cube I cap, dy j cap plus dz k cap. Its value is, so work done we want, work done equals to, this is f dot product, this is 3x square into dx into 1, I dot I, that is 1, 2y into dy, j dot j, that is also 1, plus 4z cube into dz, k dot k, that is also 1. So this is dw, work done is right as 3x square dx plus 2y dy plus 4z cube dz. This is the dot product of force and position vector. So we want the work done. There are two different positions are given. We want the work done. dw, this is right as 3x square dx 2y into dy plus 4z cube into dz. So this is dw. So integration on both sides, integration is given. So integration is given. The position vectors are, first position 3 x component and minus 2 and 2. Again this is x, y, z, x1, y1, z. And second one 4, 4, 6. 4, 4, 6, this is the second limit. So that means this is the lower limit, upper limit. We want work done. Work done is equals to, its value is 3 integration of x square dx. X cube upon 3, but limits of x limits only 3 and 4 plus. So this is 2 into integration of y dy, y square upon 2, but limits of y limits is minus 2 to 4, minus 2 to 4 plus 4 into z cube, integration of z cube, that value is z power 4 upon 4. Limits of z is 2 to 6, 2 to 6 it is. So its value, so cut करने के बाद x cube, so this is 3 and 4 plus this is 2 and 2 is cancelled, y square from minus 2 to 4 it is, plus this is 4 is cancelled, z power 4. So this is 2 and 6 are the limitations. Then the final value, this is 4 cube minus 3 cube. 4 cube upper limit minus 3 cube plus, so this is 4 square minus 2 whole square. This is the second one. Plus, this is 6 power 4 minus 2 power 4. These are the total work done value is, this is 64 minus 27 plus this is 16 minus this is 4 plus this is 6 power 4. 6 power 4, this value becomes, this is 216 into 6, follow 96. 1296 minus 16. The final value becomes, this is 37 plus this is 12, this is 1280. Its value becomes, this is 9 and this is 12, and this is 30. 130, 1329 joule. This is the work done value. In the given problem, 2 kg and 3 kg, two loads are given, both ends of a string. This string is passing through a pulley, frictionless pulley it is. Inextensible string, light inextensible strings, passing through a frictionless pulley. When this 3 kg come down due to a heavier load, and this is come down 2 meter, and this 2 kg, this is moving up, same 2 meter height. So it is come down and this is moving upward it is. Find the speed of both blocks. So this block speed V and this block speed V. The speed we want. Suppose this block come downward means loss of potential energy. This loss of potential energy gained by this body. So that means 2 kg gain extra potential energy and getting some velocity, that means kinetic energy. So this body also comes down. Initially this body speed becomes 0. This is also initially speed 0. When it is moving down, it getting speed V. When it is moving up, it is getting some speed, that is V. So that means a loss of potential energy of 3 kg is equals to gain of potential energy 2 kg plus gain of kinetic energy 2 kg and gain of kinetic energy of 3 kg. 2 kg and 3 kg both gain that kinetic energy. So loss of potential energy, how much it is loses? That is write as mgh. mgh, this is second mass. So this is m2. Second mass is m2. And into g into, this is come down 2 meter down. That is equals to 2 kg moving up. This is m1 into g into h plus this is half m into first body. This is first body getting some kinetic energy. Same as second body getting some kinetic energy. So these values m2gh, it is write as 3 into 10 into h value is 2 meter. That is equals to this is 2 into 10 into h writer, that is also 2 meter height. Inextensible string. String is inextensible. Plus half. So this is first mass, that is 2 kg into v square plus half. Second mass 3 into v square it is. So its value is, after simplification, this is 60. Its value is brighter, this is 40. So plus, this is v square plus 3 by 2 v square. Its value 20 is equals to 60 minus 40, that is 20. 20 is equals to, this is total 5 upon 2 v square it is. So this is 4 times, where v square is equals to 8. So v equals to under root 8, its value becomes 2 root 2. Speed is write as 2 root 2 meter per second. Its value 1.2 into 1.414. This is the velocity. This is 2.828 meter per second. This is the velocity gained by the two body. This body getting how much velocity? This body getting same velocity. This is in downward direction. This is in upward direction. This is the velocity. Using conservation of energy. Energy lost by body is equals to energy gained by the system. So energy lost by body or energy lost by this body, that is equals to energy gained by the system it is. In the given problem, non-conservative related problem it is. So non-conservative, that means some amount of work it is, friction की वजह से some work is done. But this work is, so due to friction is acting here. So this block is moving forward. Due to this weight is come down, this block is moving forward, the friction is acting backward direction. Once this block is come down, this block come down means potential energy of this block decreases. Potential energy of this block decrease loss of potential energy. Loss of potential energy of 3 kg. Its value becomes mgh. This is loss of potential energy 3 into 10 into h becomes 2. Its value is 60 joule. Loss of potential energy. And some amount of energy wasted due to friction. So loss of energy due to friction. So how much it is? So friction, this is F equals to mu into mg. Mu write as 0.3 it is. M is 2 kg into g. Its value becomes, this is 6 Newton. This is the friction. And some amount of, so this is displacing. So it is displaced from here to here. Then work due to friction, this is minus. Friction always, okay, this is waste the, energy. Then F into S, it is minus 6 into displacement is becomes 2 meter. Displacement becomes 2 meter because string is inextensible. So its value work done equals to minus 12 it is. So minus 12 joule, this is work done. So that means the total energy is write as total work done. Total work done 60 minus 12. This 12 is converted into other form due to this is. So friction always, this is friction always oppose the motion of the body. Friction always to decrease the energy. That means it is convert the work into energy form. So this is, so 60 milestone energy form means it is converted into heat energy. Its value becomes, this is 48 joule. This is the total weight. This 48 joule utilized to two blocks are comes in motion. This velocity is v and this velocity also v. Find the speed of both the blocks. This block having speed v. This block also having speed v. Then this 48 joule utilized to both comes in motion. So of m1 plus m2 into v square, that is equals to 48 joule. Of this is 2 plus 3 into v square, that is equals to 48. 5v square equals to 96, where v square equals to its value becomes approximately. So this is 18, 19, this is 45, 9.2, 19.2 meters. V equals to under root of 19.2 meter per second. So velocity becomes 4. This is 4 point. So this is around 4.5, approximately 4.48 meter per second. So this is the velocity of work power energy. ये कॉन्सेप्ट का रिलेटेड 6 वीडियोस अभी तक है. 6 वीडियोस में फर्स्ट 5 वीडियोस द theoretical part related with problems are completed. Last वीडियो में the only problems complete किया. आपको आगे और कुछ वीडियोस चाहिए तो शेयर एंड सब्सक्राइब करो.